thiols. Right? Thiols are like alcohols, but all I do is change it sulfur for an oxygen. So if I had rubbing alcohol, remember isopropyl alcohol, 2-propanol, whatever you want to call it. If I just change sulfur for an oxygen, now it's a thiol. Right? So that's my functional group. That SH instead of an OH for an alcohol. It's something that you're actually familiar with. That thiol contributes to smells of some things that you're familiar with, like skunk odor. It's also found in your proteins, right? And one of the reactions that we're going to talk about is really, really important in your proteins. It actually stabilizes proteins so that they can function even at higher temperatures. So we'll talk about at least one specific reaction for thiols that are really, really important in proteins. Naming thiols, you can do two different things. There's an IUPAC and then an old nomenclature. Again, if I just had that one just a second ago, if that was an alcohol, I'd call it a 2-propanol. The only difference between this and the alcohol version, it's still a 2-propane, but I keep the E. I don't add an OL. I just say propane thiol. So it's actually kind of similar. You just build off of that. So again, if it was an alcohol, I'd still say 2-propanol. So I drop the E, add the OL. Here I keep the E, add a thiol to the end of it. So I can call it a 2-propane thiol. And I could add anything else to it as well. If it was bigger, there could be more branches out in front. But old nomenclature, again, alkyl group name followed by mercaptan. Just like before, I could have called up above this an isopropyl alcohol. I'm going to call the thiol an isopropyl mercaptan, which is a really weird name. I understand that. It has to do with the fact that I looked this up a few years ago because I didn't know why it was called a mercaptan. I thought that was kind of a weird name. But mercaptan means it's talking about how sulfur can react with mercury. It can capture mercury, and that's one of the biggest problems with heavy metal poisons, right? Getting mercury in your system, it can attach itself to these thiol groups in your proteins and cause those proteins to not function anymore, right? So one of the ways that they can detect a thiol is by seeing if it will absorb that mercury, right? Or if it will capture that mercury. So that's why they're called mercaptans. It's kind of a weird name. So again, similar to your alcohol before, but slightly different. You should be able to work off of that. So again, if I had another example, this one would just be called a ethane thiol. Right? I could say 1 ethane thiol if I wanted to, but it had to be a 1, so that's not even necessary. Or I can call it an ethyl mercaptan. So if you want to use that weird word on your test, feel free to do it. Right? It's actually a correct name. Properties of thiols, they're a little bit more polar than hydrocarbons, but less polar than alcohols. So they would have a boiling point somewhere in between that of a hydrocarbon or an alcohol. They do have low solubility in water because they are relatively nonpolar. Not a whole lot of things that will end up on a quiz here, so don't worry about that too much. But the reactions for thiols, this is something I definitely want you to know. I need you to know. So we have these disulfide bridges that are going to form. can be broken. Right? These are actually two different reactions on the slide here. It's actually going to be an oxidation that will form a disulfide bridge, and it's a reduction that'll break that bridge. Right? So this is just generic. That's maybe not as useful as a real example. So if I gave you a thiol, any thiol, again, it could be my isopropyl mercaptan and an ethyl mercaptan. Right? They do things we just saw. If I react those two things together and I have some kind of oxidizing agent, I can make a bridge between those two things. Right? So all I'm going to do is take that sulfur and remove the hydrogen and connect it to the other sulfur and the other thiol, and it's still going to have the same amount of carbons hanging off of it. I still have an isopropyl on the one, and I have an ethyl hanging off of the other one, but now I have a bridge that connects those two things. So we have this disulfide bridge. And again, in distant parts of proteins, that can actually connect. These bridges can connect that protein together and stabilize it, make it so that it stays that way, right? So it's actually really important in some proteins in your body, right? More so important in like an archaebacteria's body that survives in boiling water, but disulfide bridges definitely exist in your own proteins. So this can be a really important reaction. On the flip, I can also break these disulfide bridges. So if one already existed, and I don't really care what those things are connected to, again, they could actually just be connected in a ring like this, right? Who knows? But if I have two sulfurs that are bonded together, that's a disulfide bridge, I can reduce that. I can use a reducing agent to break that bridge, to break that bond. And all I would have then is still, okay, make sure we understand that there's 1, 2, 3, 4 carbons in this that are still connected together. So I'd make a 1, 2, 3, 4 carbon chain. And on each end would be a thiol group, right? That SH. It's also kind of an interesting one. It would be a dithiol now, right? But we don't have to worry about those. I don't have you name those on tests. So not something that you have to worry about naming right now, but you could see a look like this. So I can make these bridges and I can break them, right? One important connection to this, the reason why maybe you're even familiar to this. I talked to you guys in class, I think, at one point, and I asked who had ever gotten a perm. This is the exact reaction that they use in perms. So if you've ever had a permanent, right, the first thing that they would do is actually put a chemical in your hair, treat your hair with a reducing agent to break these disulfide bridges. But then they would put a different chemical in your hair, both of which smell really bad. I don't know if anybody's ever been around that. But once they put that second chemical in, it reforms those disulfide bridges, but they've already put the curlers in so that those bridges are formed in a specific shape. And that's why your hair stays curly after the fact, right? So we take advantage of this reaction in some weird ways, some unique ways. But generally speaking, this is used to make a globular protein more stable so that even at really high temperatures, that protein, that enzyme can still function, right? But again, we can use it to curl your hair too, apparently. So that's your thiol reactions. That's all you need for those.